We talked about humans, we talked about artificial intelligence, now we talked about genius as intelligence. The last missing piece is, of course, natural intelligence. So how can we collaborate with and use nature's intelligence to work for us? And so our last speaker today is Petra. She's an architect at the long-time member organization of Media Evolution, FOIAB. At FOIAB, she is one of the instigators of FOIAB Code that investigates how computational design brings new possibilities to the design of cities, architecture, and city development in general, I suppose. Please welcome Petra.
Thank you, Martin. Yeah, I'm an architect, so I'm going to talk about buildings. And I'm going to bring this sort of very digital talk into the more physical realm. And I guess all of you are not sort of working with buildings every day, but we all have relationships with buildings, and we are in one for now, for example. So if in doubt, think about this one. But we'll start with this little creature. It's an axolotl. It's a little superhero. It has superhero powers. If conditions change, it can go from being a water-living animal to a land-living animal, for example. And if it would lose a limb, it can regrow it. Superhero. And the question then is, can buildings be superheroes? Could we imagine buildings that can change if conditions change, that can heal themselves if they break? Today, not so much. We're quite far from that, I'd say. There's something in that we work with buildings in a reductionist manner, and we think about elements of building as discrete units, while the axolotl is very much an interconnected, intertwined system. And it can reach another level of complexity. So we're thinking about buildings as being very, very complex today, but we're nowhere near that complexity. So how could we shift how we work with buildings and think about buildings to reach another level of complexity and see what buildings could be and do? I'm also going to go do a little retrospective. I'll go further back in time. Pre-Renaissance, we're sort of 1500s that time. People were makers and doers at that time as well as we are today, but they were doing things directly with their hands. And they were, while doing that, they got feedback. They could feel the materiality. They could sort of, you feel things with your hands, and they could work with that. And then came Renaissance, and we learned the fantastic sort of innovative thing of making drawings. And drawings are absolutely great, but they are great at sort of communicating geometry. They are not so great at communicating materiality, behavior, how things feel, what they do, how they change, how they decay, all these things that are embedded in stuff. We can't really communicate with the drawing. And then we come up to the 60s, and ta-da, we got computers. And we're sort of somewhere at this very far end in what we're talking about today, right? But I'd say that the building industry, we're still sort of in the Renaissance time. With the computers, we start to understand the logic behind things. We start to understand how we can write code and how code can write itself. And we start to understand that there are things behind the expression of something that is this sort of process that does something in the end, or makes something, creates something different. We start to understand DNA, we start to understand our bodies, something different, and then the sort of Renaissance man. And again, we can work with feedback, and we can get intuition, and we can get back to that sort of the things, the understanding of behavior and properties in a way that we couldn't when we communicate with drawings. So I'm going to show you a few examples of a little bit of sort of snippets of people working in this way and thinking in this way, and what that can do. And these are examples of material computation, so not letting computers compute, but letting material compute. And first out is Professor Mingus. He's at the University of Stuttgart, and he's been doing these beautiful little leaves of laminated wood. And normally when we laminate wood, we do it in with a cross lamination so that we take away the behavior of the wood. We don't want it to bend. We don't want it to be woody and natural. And what Mengus has done is that he laminates it in a way so he enhances the behavior. So as soon as the humidity in the air changes, these little leaves, they curl up or they flatten out, making those window shutters close just before the rain comes. Beautiful. Another example is this project by a group of students at the Architectural Association in London. And they were going to do a little structure to hold up a roof. And they started by thinking about trees. And that trees, when living, they optimize their cell structure to carry the load that the tree needs to carry so that it doesn't break. It can hold itself up in different weather conditions. And of course, when you chop the tree down, it still has that load-bearing capacity. And normally, we would cut up straight planks out of it and sort of lose the specificity of that load-bearing capacity. But what these students did was that they went out into the forest, they 3D scanned a lot of trees and found a lot of different load cases in these sort of different forks. And then they designed a truss that had similar load cases. So they could use what the nature had optimized for during the time the trees were living. They could use it in the same situation later on. And they did this with an evolutionary algorithm, and they produced it with a robot, and you see, yeah. Then I want to show you a project that we've done at FOIAB. Maybe not as advanced, but here this is something we started out doing back in 2014, 15, something like that. We were interested in what happens when you fold something along a curved line. And we started taking a scalpel and cutting pieces of paper and folding things, and said, oh, beautiful stuff happens when you just by the simple act of folding along a curved line. We went to a local company that do things in sheet metals and said, can you help us? And they said, yeah, we can. And we did this at the top here, 2 first prototypes, and we were amazed. Wow, those are super beautiful. They're a little bit wonky and stuff, but this has potential. But we also realized that we can't design this in the way we normally design. We can't say, this is the shape I want, do it for me. We had to give the curve that would give a shape. But we didn't know what shape we were going to get from what curve. So we had to sort of design in a different way. So we went back and we did a little computer program that simulates the bending and the folding. And we could then fold these in the computer, and we could unfold them, and we could start to realize, okay, these curves do this, and this. You see, we could build up an intuition around this. And we could also figure out if you want a square panel in the end, since square things are good for buildings normally. You can't start with a square panel, but you have to start with something else, and then you get a square panel. So, but what do you start with to get the square? And then, we did lots of tests, and a few years later, we had this prototype that we could build, and then we started feeling confident, and we said, okay, let's put it in a building and propose it to a client, and they said, yes, love it. This is for a mobility hub up in Västerås, and last year it got built. And it looks like this, and we are super happy and super proud of this process. And one of the best thing is that these come flat packed to the site, and then they get bent on site and put up. So also sort of reducing transports. I don't know how long I've been going for, but who knows? Yeah. Oh, I'm gonna finish too quickly. Yes. Okay. So these are little, I don't know, little pieces in a puzzle showing, hinting towards where the construction industry and the sort of people working in the built environment could go. But sort of okay, if we try to extend that and look into the future, where are we going? And now I need to walk up closer to the screen. Here is a quote by Owen Hopkins, and I think it sort of gives us some clues. So I'll read it out loud. Even today, construction, use, modification, demolition, or decay operate as discrete moments in a building's lifespan. Very rarely does one blur into another. Post-digital turns this on its head. If architects become craftspeople, designing and also constructing through robotic technologies, then buildings can be designed as they go along. And if construction is run by a computer program, it will be inherently reversible, with buildings able to be continually redesigned, rebuilt, reworked, augmented, demolished, and reused. Let's go see through what he's actually saying here. So first, he starts talking about that the different stages of buildings are discrete moments. And that is how we visualize this in the industry. First, we have a phase of planning, and then we have a phase of building, and then we have the use phase, and then something happens towards the end of the building's life. As an architect, we're normally involved in the planning, a tiny bit in the actual building, and very, very little in the rest. And of course, this has some issues. First of all, I think we sort of want to move towards a circular economy, and this is a very, very linear line. So there's a mismatch there. But also, in this way of operating and working, it's really, really hard to learn and get feedback from what actually works and how things actually are performing when we are deciding what this should be. So obvious sort of faults in this system, I'd say. Continuing, he says that if buildings can be designed and constructed through robotic technologies, we can design them as we go along. And this challenges what we think of as the design, the designer. What are we doing? All of a sudden, we are moving away from doing the drawing ahead to something that happens in an instance. You mentioned something about that previously. That sort of how it reacts in real time. And that means that we have to do that shift from Renaissance mode of operating and planning and drawing ahead to going into setting up systems that can react and work in real time. Yeah. So we are then going from the sort of towards the computational way of working and working with the logic that is behind things. And then he continues with that if construction is run by a computer program, it will be inherently reversible, and this is huge news for building industry. Reversible buildings that can just change, do things, whatever. Maybe you come into the office and it's another office than you left the day before. Who knows? And this also means that we need to think about the building as a digital system on its own. We're not only having sort of, here is the digital and it can produce things that then become physical. But the digital and physical are interlinked, and they're becoming one. The building becomes the intelligence. Of course, in that case, it needs to be able to work with the local materials of what's at hand. It needs to be able to work with the very specific situation and of the inhabitants or program having, and there are lots of sort of I think it shifts. It shifts it down to being in the present in a way that we're not thinking about buildings today. There's something in the future or over there. So then, what are we saying is that we're no longer in this mode of working, but we're rather in this very, very sort of mishy-mashy situation that's happening continuously all the time. And this could, of course, you can see that this can become circular. It was just too hard for me to do in PowerPoint. And then you're thinking, oh my God, she's out on a limb. What is she talking about? And then I'd say that we can see lots of beautiful examples of this way of thinking about built structures if we look at nature. For example, you could have a look at termite mounds of sub-Saharan Africa, created by these little creatures in colonies that are working without planning, without any drawings, and without any hierarchical structures that tells them what to do. So a community that together can build amazing, well-performing structures. So can buildings be superheroes? Who knows? Maybe. I hope so. I think we're taking sort of baby steps towards that. I think we're starting to rethink the built environment and our relationship to it, and very much through the digital and other forms and shapes of intelligence. Yeah, that's all for me.